Today we're going to talk about how to multiply and divide with scientific notation. Now we have three main steps. The first step is going to be to regroup our decimal numbers and our powers of 10. The second step is going to be to multiply or divide. And then the final step, and this isn't always necessary, but the final step is going to be to write the answer in scientific notation if it's not already in scientific notation. Now let's go to example 1. First step is going to be to regroup, and I'm going to regroup using the commutative property of multiplication. I'm going to regroup my decimal numbers, in this case the 6 and the 9. And that's going to be 6 times 9 times, now I'm going to regroup my powers of 10. My 10 to the negative 5th and 10 to the negative 12th. I know that 6 times 9 is 54, times, notice when I multiply these powers of 10, they have the same bases, and when I'm multiplying two powers with the same bases, I'm going to add my exponents. This is going to be 10 to the negative 5 plus negative 12. That's going to give me 54 times 10 to the negative 17th. Now when I look at this, I realize that 54 is not in scientific notation. In fact, I really need this to be a 5.4. I need to move my decimal 1 unit to the left. Now, as a side note, let's talk about how we can do this. Suppose for a second that I have 50, and I divided it by 10, and then I multiplied it by 10. Well, 50 divided by 10 is 5. Times 10 is 50. When I multiply and divide a number by the same thing, there's no net difference here. I started out with 50, I ended with 50. We're going to do the same thing here. I really need this 54 to become smaller. Now to balance that, I need this second part of the number to become bigger. I'm going to make this happen by dividing by 10 and multiplying by 10. Noting that there really is no net difference. We start and end with the same value. We're just rewriting it in a different form. So to make 54 become 5.4, I'm going to divide by 10. And then to balance that, I'm going to take this 10 to the negative 17th and I'm going to multiply that by 10. So I end up with 5.4 times 10 to the negative 17th times 10. That's going to make this larger. This is going to be 10 to, now I want you to be careful when you're dealing with exponents. If I have negative 17, a lot of people might think, oh, well, to make that bigger, that's going to be negative 18, because 18 is a bigger number. I want you to be careful here, because bigger is going to be to the right of that, and that's actually going to be negative 16. And this is in scientific notation, and this is our final answer. Let me delete that, and let's do the second example. For the second example, we have oops, let me just switch to my hand tool here. I want you to notice that this is a division problem. But instead of writing it horizontally, I prefer to use a fraction bar. And so I'm going to write this as 2.05 times 10 to the 8th divided by, which I've done with the fraction bar, 5 times 10 to the negative 4th. So we still need to regroup. I'm going to regroup my decimal numbers like that. I'm going to regroup my powers of 10, and we're going to perform this operation. We're going to perform this division. So 2.05 divided by 5 I can write 2.05 divided by 5 times, this is going to be 10 to the 8th divided by 10 to the negative 4th. And 2.05 divided by 5 is 0.41. times, remember our property here, when we're dividing powers that have the same base, we subtract our exponents. So this is going to be 10 to the 8th power minus a negative 4. This is going to be 0.41 times, when I'm subtracting a negative, I'm really adding. This is going to be 10 to the 12th. So then we ask ourselves, is this in scientific notation? And the answer right now is no. I need this 0.41 to become 4.1. I need to make it bigger. And to balance that, I need to make this 10 to the 12th smaller. To make it bigger, I'm going to multiply by 10. To make it smaller, I'm going to divide by 10. Again, there's no net change. We're just rewriting our answer in a different format. So I end up with 4.1 times 10 to the 11th. That is in scientific notation, and that is our final answer. Thank you so much.